Welcome to the Science Week, and this is a talk that I'm giving on behalf of myself and a couple of colleagues. Dan Goddard, which is the chap's name there at the bottom. Dan Goddard was an MSc student who worked with us for a year last year, and who's now working as a design engineer in the field of recycling, actually. And my colleague, Prof. Andrew Kennedy, is also involved in this research. So I'm going to talk on their behalf about the opportunities that exist for recycling textiles, recycling all materials really, from mattresses. So that's something that hopefully you'll find interesting, and it's something that's been keeping me and my colleagues busy for some period now, because the use of materials is something we care quite a bit about. So just to move on this all fits into, I thought I'd start with a quick overview of where this sits in terms of what we should all be concerned about. So the UN Sustainable Development Goals, which hopefully all of us have heard of, are a series of priorities that have been identified. The strap line at the bottom there, it's a blueprint to achieve a better and more sustainable future for all of us by 2030. So all these development goals have been defined. And when we're thinking about materials in particular, if I can get my slides to work, for materials particularly, we're thinking about how we deal with materials in terms of how we obtain them, how we process them, how we perhaps recover and recycle them, and that's what this talk is thinking about. But the Sustainable Development Goals that particularly are of relevance to this work into materials generally, we're thinking about innovation and infrastructure, which is goal number 9, responsible consumption, which is all to do with what we use, how we use it, and then what we do with it at the end of its life. Protecting the planet, so that's greenhouse gas emissions really. And then also we've got life below water, because often in terms of materials particularly, if we're losing them from the system that we're controlling, often that has impacts upon the aquatic system. So that's also of relevance to this particular work. So if I'd start with where it matters in terms of the environment. So if we're thinking about global gas emissions, CO2 gas emissions, there are 3 donut charts here, which just go through where the CO2 in the world is coming from in terms of the analysis. So if we're thinking about this one on the left here, we've got deforestation. About 36% of all the emissions are due to that. But then this blue section here, about 64% are due to energy and processes. So that's generation of CO2 due to things that we're doing in terms of industry really. If we take the next one along, so this is the blue section here, 64%, okay, what's that made up of? Industry, 35%, so that is making stuff, using it, shaping it, fabric into different shapes and sizes, into different processes. 35% of those CO2 emissions are due to industry. Transport, that's moving things around. The built environment, that's keeping our buildings warm or keeping them cold, depending on whereabouts those buildings are based. So we've got a lot of energy use in terms of making stuff. And then if we look at what is being made, the last donut here goes through those different material classifications, and there are some real notable material types there. So steel is about 25% of all those industrial emissions. Cement is about 20%, 19%. Paper, plastic, and aluminium. The others are in this remaining section. But you can see from this that steel, in particular, is a big user, consumer of CO2 in terms of its processing. And cement as well, which of course impacts on the built environment. So CO2 is associated with, if we think about materials, it's getting stuff out of the ground, perhaps it's refining, it's processing, all the stuff that we do along the way to producing something that then we go to the shops, buy, obtain, use, and then we do something with it at the end of its life. So we're thinking about in use, maintaining it, and then decommissioning it and reworking it, and then recycling, hopefully, at the end of the day. So this particular talk is thinking about, okay, what do we know about this when we come to think about mattresses? Is that process working very well? If we think about a single material, think about aluminium, which is a good example. We're familiar with aluminium, with drinks cans, with all sorts of stuff that uses aluminium, with aircraft, so on and so forth. A single material is fairly easy to think about. It flows through life. So we've got, this is for aluminium. We've got aluminium making, which is electrolysis and melting. We cast it, we do all sorts of stuff with it. We perhaps draw it down, we form it and so on and so forth. Then we shape it, and then we do stuff with it. We make our drinks cans and other things. to optimize this process, which is often what we're thinking about in the materials cycle, we want to be doing at every opportunity, minimizing losses. And if we have got losses, ideally, putting those losses back into the system. So good design, good sustainable use materials, we're thinking about, if we start using less stuff, but if we have to use it, make it very efficiently, make sure that any scrap in material processing goes back into the process, and then also make stuff last as long as possible. And then when at the end of life, think about what we're going to do with this at the end. Can we get it back into cascade into something else, or upgrade it into something that we can also use? And also, of course, reduce demand in the first place. So for aluminium, this process has been really well optimized, and for steel as well. So steel and aluminium, this is really very efficient now. None of the aluminium that you'll see and come across has not been through the recycling process. It's really optimized now in terms of materials usage, which is great. When we think about real things, we tend to combine materials. So if we think about, I've got a house, a car, a carpet, and a mattress here. If we think about any of these products, we've got lots of stuff involved. And depending on what we do with them, and depending on what their application is, energy gets used on the way through. So think about the car. The majority of the energy is used in driving the car around, in fueling it, in keeping it doing what it needs to do. So once we've built it, it's going to use lots of energy in life. A house is a bit of both. We've got to use materials to make it, but then we've also got to keep it warm or cold, depending on where it is. Something like a carpet or a mattress, which is what today's talk is about, the majority of the energy input, the CO2 input, is in the material usage at the start. So we need to make sure for these, we're not really bothered about the energy in use. We're thinking about, okay, those materials are where the value lies. So we don't want to be losing those materials. We want to be ideally minimizing the manufacturing costs, reusing materials in the manufacturing process, for example. This is quite well explained and quite well exemplified in the Ellen MacArthur Foundation's circular economy diagrams, whereby we can think about the circular economy, but it's got lots of different stages to it. So we've got a stuff in at the top, we've got stuff out at the bottom, we don't want any of that, but really we'd like to use materials, we want to make them, we'll pass them on to a product manufacturer who'll put them together into something like a car. Somebody will then do something with it, perhaps a retailer, and then finally we get it and we either use the materials, which is the blue one, or perhaps for the organics type of things will be a consumer, which is on this side. But if we think about the blue side, which is the materials usage side, there are certain ways through this recycling loop that we can think about that are better than others in terms of the energy we're going to lose on the way through. If we recycle stuff, take it right down to pieces, put it back in the top, yeah, that's good, we're not losing anything, but actually we're losing an awful lot of value in terms of the energy that's embodied to break that thing down, to get it back into a recycled product. If instead we actually return it back to use in its original form, that's the most efficient way, the most circular in terms of additional energy we put in. That's the best way of dealing with things. So there are some nuances here that we need to be aware of. And as consumers, this should really be informing a lot of what we do and what we think about. And it's getting more obvious, it's getting more prominent in many products. So that takes us to mattresses. Haven't we got a problem with mattresses? There's a lot of them, and they're not at the moment very well dealt with. So in the UK, 5 million mattresses are sent to landfill in the UK every year. That number's going down, driven by legislation, but it's a problem, and what do we do with them? So it's still a problem, it's going to be a problem for a long time. So the project that Dan was working on, that Andrew Kennedy and I have been involved in, is thinking about how do we get our heads around this and what can we actually do to perhaps understand the processes and to think about options that are available. And there are lots of people looking at this problem in addition to ourselves. So if we think about the mattress problem per se, mattresses piled up, if you can imagine that, they go a long way because there's lots of them. They're low volume, well, they're big volume, they're low density. So there's an awful lot of mattresses to deal with. What do we do with them? If we think about what's in them, back to that circular economy diagram, 95% of the stuff that's in a mattress could be reused or recycled. And that's the challenge. And if you put them into landfill, well, that's it. You're not going to get anything out. If you put them to energy from waste, yes, you can liberate some energy from them, but all that material has gone. So it's the least effective way of dealing with them in terms of energy from waste. So this is the problem, this is the challenge, and this is the opportunity in terms of materials opportunity that is of interest quite clearly. So if we think about the mattress life cycle, so Dan spent a bit of time just really getting some numbers and doing some surveys with manufacturers and working with stakeholders in this area to think about, let's first of all define the system. So the system for a closed loop system, the boundaries are defined as this hatch line here. And so the material comes in, the component supplier, mattress manufacturers, vendors and customers, around we go. Mattress recyclers would be here. And then potentially we could take mattresses and people and send them back into reuse, for example. This doesn't really happen to any great extent. Or we could think about this shaded area here, whereby we're saying, okay, let's liberate some value from these materials, perhaps through secondary markets, perhaps through energy recovery, or at the moment, which is the main use now, the main application, main end use, into landfill. So it's this shaded area really that is the area that needs more understanding and needs optimization compared to what currently happens at the moment. If you compare that to the circular economy diagram, we can see that we're not really operating here in the optimum level. We're operating somewhere else here. And really, we're losing stuff because if we put it into landfill, well, it's gone, it's out of the system. Energy recovery, it's gone, it's out of the system. Secondary markets, potentially, that can be into a closed loop, into a different closed loop, I suppose. So you can see if we're striving for this at the moment, this isn't really working terribly well because of this problem with the reuse side of things, which really isn't working very well at the moment at all. So in terms of some details around that, which is what we've got some numbers on, and there've been one or two studies looking at this, 8.4 million mattresses are consumed. This is the UK data from 2018. 90% of those are disposed of, if you like, can be traced. 7.5 million total is going into the system, and of that system, the local authorities pick up the lion's share, so 3.75 million, and they end up in landfill at the moment. At the moment, I think the UK is running the latest data, it's about 20% are being recycled. So still lots of landfill, still a problem, still lost materials. Incineration, path of least of I suppose, the option if you don't want to put it into landfill, still significant, represents a lost opportunity. So the recycling is there, but the project really is thinking about, well, could we do more with this? Can we increase this number? So what are the challenges? What are the challenges presented? Well, there are one or two obvious challenges. To take a mattress to pieces to recover these materials, it's a very difficult thing to do. It's labor intensive. It's not particularly pleasant work. It doesn't lend itself to automation in a trivial manner. It takes some manufacturing capabilities and some design to be able to disassemble these things effectively and efficiently. So you can see there's a couple of chaps that are basically getting in there with Stanley knives, with PPE on, to separate the materials. And you can see from that, there are quite a few different bits of materials involved. And that's part of the problem with these things. There's lots of different materials in there. So the processing cost per mattress, if you look at the economics of the UK system, it's about £3 to £5 to process. And the gate fee that the processor can obtain, so when you take your mattress or get it collected, the charge to get rid of that is £4 to £6. So the margins are very small, if at all. And then you've got the problem if you're going to go through either a manual deconstruction or an automated process, you've got to put some money into to produce the facilities. And at the moment in the UK, there aren't enough of these facilities, and there certainly aren't enough automated ones. And part of the problem with that, of course, is the setup cost to do this when you've got very small revenues involved. So the market per se isn't working very well because it's been left to its own devices, really, and the manufacturers haven't really been particularly minded or required to do much about what happens at the end of life side of things. So at the moment, the on markets for the materials that are liberated from these types of mattresses, we've got lots of polyester comes out, that goes into animal bed filling, so pet beds, that kind of stuff. Polyurethane foam, that tends to get used for acoustic panels for automotive applications, for example. So it's taken out in strips, baled up, and then that gets crumbed, it gets ground down to produce something that can be rebonded together into panels. something called shoddy. That's the industry name for a general mixed recycled fibre of varying origin and varying mixed materials. That separates the springs from the top layer. So that's put in there as an extra layer. That gets used for equestrian surfaces at the moment. So that gets taken out and it gets ground down and it gets used for horse applications, for equine uses. And then the mixed textiles, which are really all mixed, all sorts of stuff going on in there, that tends to go to solid recovered fuel. So that's energy from waste. If you then look at the costs involved and the material that can be liberated and the market values, which is a challenge really. If we take the 3 different types of mattresses that exist, you get open coil, so you've got the spring center, some shoddy there and some comfort layer. And then we've got the top and the bottom, the thing that you'll see when you go to wherever it is you go and look at mattresses. They look similar from the exterior, but interior-wise, these pocket spring versions, which the UK has got quite a high percentage of, I think it's about 40% of UK mattresses are this pocketed spring design. And so there's a fabric put over each of the springs, and that makes for a very difficult to separate structure because you've got non-woven fabric wrapped around the springs, put in there at manufacture, and then it all gets cased in, and it's very difficult to separate. And when these things go through the shredders and the crushers at disassembly stage, all those pocket material basically becomes a problem in terms of causing the machines to fail and to jam and to do all sorts of things. So there's a problem with that design per se in terms of how easy it is to separate things. And then we get the foam and the latex versions, which don't have the springs and they've just got a big pad of latex. So you can see from that, you've got all these different materials involved. One manufacturer, for example, has got 32 different materials in a design of a mattress. So in the other, there will be these additional types of materials. So there are all sorts of bits of finishing, edging and stuff like that, and staples and wood and cardboard, bits and pieces all mixed together. Very difficult to separate, and that's the problem with these things. So the margins are very low, that's a problem, and they're difficult to retrieve the materials full stop. And of course, the other problem really, that's if you've got something, that the mattresses came in looking like this. The problem, of course, is that you get mattresses that cannot be in a condition that lends itself to recovering the materials. You've got to get the mattress from wherever it's discarded from the consumer to your recycler. You've then got to store these things and ensure they don't get further damaged or deterioration occurs whilst they're being stored. And then, of course, when you take the materials out, you've got 32 different materials, as you can imagine. Some of those materials won't be in great quantities per mattress. So the baling that's required to store the materials until you get to an economic size for further disposal, for the next processor to buy from you, again presents a problem with regard to storage. So big sites are required, which again is an overhead for these things to occur, for these things to be viable as a business. So there's a problem with these materials generally. There's a problem with this storage, this stage in the circle, if you like, of what you do with these things on the way back to their next role in the material cycle. So we can sort of summarize all that and say the access in the downstream markets, where do you send these things when you've retrieved the materials? Where are they going to go to? Those markets, are those markets at the moment willing to take the materials that are recovered? The logistics and economics of moving these things around, they're big sizes, but they're small weights. So you've got to put large vans perhaps around to pick these things up from places. Downcycling materials, you're going to lose value. That's material cycle. That's further out. That's a bigger diameter circle on the circular economy diagram we saw earlier. High investment costs for the waste stream processing if you're going to automate the process. That may be a possibility, for example, for financial easements, to think about loans, think about grants for that to happen. Of course, that requires perhaps central investment, government intervention. And then we've also got, at the end of the day, we've got a few drivers for closed loop recycling, because at the moment, the extended producer responsibility doesn't extend to mattresses, although I think it is likely to occur. So from the point of view of the manufacturer, there's no requirements, unlike the automotive sector, for example, to actually think about take back, to think about, okay, when this thing's finished, what happens to it? So these are the main problems that exist in this area. So one of the things that we could also think about, and part of the project looked at, just for completeness really, is to think about the built environment, because the built environment is a significant CO2 user. So what about, could these fibres, these retrieved materials, perhaps have applications in built environment materials. So we're thinking about cements and plasters. These are high volume materials used extensively, and potentially as a filler material, so that's taking the place of an expensive component. So that could be taking the place of an ordinary Portland cement, for example. Fibre reinforcement will likely minimise the chances of cracks progressing as readily through the material if you put a fibre reinforcement in a brittle material, and or, for example, insulation, be that acoustic or thermal. So we ran some experiments in the university, in the engineering department, to make up some blends with fibre and with polyurethane inclusions. So the way you do this is you make standard test specimens. That's a 50mm cube, and this is a beam specimen, both of which, when they're loaded, the amount of force that's taken to break them and the amount of deflection prior to breakage occurring give you some information as to how the material behaves from a mechanical point of view. So that's an important measure that we have for materials without these additions. So if we do the same experiments with the same sorts of samples, and we do enough often, so we've got statistical insight as to the kind of behavior we can expect, that can give us a measurement that we can compare how these materials would behave if these things were ordinarily part of the, if you like, the ingredients used to make them. So if we do that to show the data we've got here, just to show it's a science presentation, show you some data. So we've got strength on the y-axis and we've got total percentage of something added. The two left sets of bars are control samples, so they've got nothing done to them out of a normal sample. But the other ones here, we've got some addition of these materials. 0.25% doesn't sound a great deal, but of course these are percentage in terms of the volume percentage. So actually that's, from a volume point of view, that's stirring quite a bit in. So samples are made with additions of latex, that's the foam, with additions of polyurethane, different type of foam. This is into cement. Next one is into plaster, same sort of thing. But in this case, we've got the fibres now into plasters. So if you put them into plasters, you can measure the cube compression, so that's squashing the sample. What force can it take before it breaks? If you divide that by the area, that gives you the strength. From the point of view of compressor stress, if you think about the beam flexure strength, that's bend a beam, when does it break, what stress is involved in that breaking. Same thing for the cement, same sort of specimens. And what we can conclude from this, the data's noisy, that's what we expect. These are real materials, they've got lots of defects in them. But effectively, you can put some material in there, some of this addition, taking the place of the normal components. And the performance doesn't change materially if you don't put too much in. So there is a possibility, if the manufacturers, the gypsum producers, the cement manufacturer was close enough to, for example, the recycler, potentially you could add some in and you might get away with it in terms of materially not affecting the properties. And this is what happens now with, for example, rubber tyres, recycled tyres are put into cement, the cement manufacturer, because it's a way of adding to and reducing the expensive, the energy intensive component. So there is a possibility of doing that. The study has shown that, but it's early days and it's not going to be a game changer, but it is possibly something that could be of use. What else could we do? Well, we can look at our peers elsewhere, not in the UK or not in England. For example, in Australia, social enterprise model, soft landing Australia. This is essentially changing the economics of the process by saying, okay, we've got this thing as a problem, but we've also got the opportunity to employ people. So it's a social enterprise model, very successful, significant numbers of mattresses are going through. In France, the UK Mobilier have got a system whereby there's a taxation levy, if you like, placed upon, and they've got a commitment to zero target furniture landfill by 2023. Zero Waste Scotland, for example, is now seriously thinking about the extended producer responsibility. So that will place the responsibility onto the manufacturers to say, okay, you've got to think about this at the end of life, what's going to happen? There's an example here, which is also the social responsibility model, the excuse me, social, akin to the soft landing. This is an island, thinking about employing people at the same time as dealing with the recovery of the materials. So that's that, you know, it's a way of altering the economics, really, to say, okay, this is something that's worth doing, and we've got added value other than just the financial bottom line that enables this to happen. Other projects here, which is funded by the EU, which is Resyntex, which is thinking about chemical recycling of polyurethane. polyurethane's a problem. The economics of that again came out, they've just reported it's challenging. If it's just left to the market, the economics are marginal, to say the least. However, with government intervention or with taxation, that could tip that into viability. And the Netherlands, just the last point I've got there, 95% mattresses, recycling rate headed for 2025. So elsewhere, the mattress problem is not as dire, not as unaddressed, if you like, as in the UK. So there are things to point to look at in terms of making changes. So to conclude, I think I'm probably, excuse me, what can we say from this? What are the take homes from this? Materials aren't at the moment being very effectively used in point of view of mattresses. Nobody's in any doubt about that. The opportunities really arise from manufacturer take-back schemes. It's used in other industries. Once that happens, the design for remanufacture, the design for disassembly will occur, because it then is in the manufacturer's interests to think about how can we either get the materials out more readily, or how can we actually use some of the components back into manufacture again. The spring units, for example, at the end of a bed, at the end of a mattress's life, the spring units are perfectly okay from the point of view of their load carrying capacity. If they were hot dipped, if they were galvanized, they would have a life probably 1 or 2 cycles quite feasibly. So there's a possibility there that currently isn't being exploited. And this is used effectively in many other industries. Once the manufacturer has to think about the end use, at the design stage, they can design out the problems of all these different mixed materials. They can simplify the assembly, they can simplify the disassembly at the same time. Social enterprise models, we've seen that works elsewhere. That just takes the edge off the financial imperative, if you like, because there are other benefits to be had. And so in the round, that's something that makes that worthwhile doing. Consumer demand, that's the last one here. That'll really start to drive change. If we start to all think, okay, ask the questions, how do we know where the stuff goes when we buy it? How do we know it's been sourced responsibly? How do we know that it's going to be disposed of responsibly? In the textiles industry now, in clothing, this is really changing in a significant way. And if the same thing were to apply to mattresses, I think, again, that would make a big difference. And then also, lastly, we've got new applications and markets. That's always going to be an ongoing imperative, because there will be things can be used for that haven't yet been optimized or haven't yet been thought about. And once this is tied in with the manufacturer's responsibility to design with a view to what can we use at the end, those two tied together will start to change the viability and the options that come out of all this.